quickest way to do this question, I think, is to draw your 8 centimeter line. Like it has to be somewhere, so why not just draw it as the horizontal line and draw it first? And then we need to, well, we can draw a 6 centimeter line. Now, we might as well draw it on the right because it's going to be the same. We're just going to, if I draw it on the left, it's just going to be a reflection of the other triangle. But, that will still give you this. If you draw it over here or over here, you'll still get like the other length being the same essentially using like by reflecting it. So if I draw the 6 straight up, I'm going to get an area of 24. That's going to be too big. But as I like bring it round, the area is going to decrease as the height of the triangle, the perpendicular height of the triangle decreases. And there's going to be a point where I hit 7. The reason being, if I bring it all the way down to the bottom, it's going to hit 0. So there must be that somewhere between 24 and 0, I will get to 7. So I'm not saying this is drawn accurately or anything, but that is definitely going to be a possible triangle. Now, are there any more? Well, let's do the same sort of setup, but this time, instead of going to the left, we'll bring it around to the right. And the same sort of argument, if this is 24 and this down here gives you 0, there must be somewhere in between where we get to 6. Sorry, an area of 7. So let's say that is 6. As I bring it down, I'm going to get my area of 7. And therefore, just like by considering these triangles, we can see that the answer is going to be 2. I'm just going to talk about one other method for solving this problem. It uses more advanced ideas, but it's a little bit more rigorous and you can be really sure that there's only 2 solutions. So for this, I'm going to just draw another triangle. I'm going to say that this is 8 and this is 6, and I'm going to label my angle capital C. Now, as well as us having the area of a triangle as the half base times the perpendicular height, it's possible to show that it's a half AB sine C, where A and B are any 2 sides. C must then be the angle in between. So in our case, it's going to become 24 sine C. What we are interested in is where sine C becomes 7 over 24, because that will get us our area of 7. So I'm interested in solving sine C is 7 over 24. For this, we need knowledge of the sine graph. Okay, the sine graph starts at 0, it comes up and down, it oscillates like this. In fact, it oscillates forever. This here is 360 degrees, and here I've got 180 degrees. For a triangle, the angle C must vary between 0, well, it can't equal 0, but it must be greater than 0, but less than 180 degrees. And so I'm interested just in this first section of that, where sine C is equal to 7 over 24. So it's where the horizontal line hits it here, and this is 7 over 24. You can see there's going to be an acute angle, which in fact corresponds with this acute angle here, and there's going to be an obtuse angle, which corresponds to this one. So yeah, even more careful, this shows that there are 2 solutions.